The title of this presentation is Effect of Solar Wind on Typhoon. The reason why typhoon occurs in spring to autumn is that the areas where trade winds and westerlies wind blow changes depending on the season through the tilt of the Earth's rotation axis. Its trade winds and westerly winds are driven by solar winds that are blowing from the Sun. That is the effect of solar wind on the typhoon. The center of the irradiated Sun's surface moves along the same latitude by the Earth's rotation, and the heated atmosphere also moves. The effect of the solar wind, which passes at high speed in the east side of the Earth's atmosphere, colliding with atmospheric molecules to move from west to east, is greater than the effect of solar wind on the west side that move atmosphere from east to west. The chains of magnetic coupling between moving charged particles keep the movement of the Earth's atmosphere faster than the Earth's rotation. The solar wind has a rotation component of 1.89 km per second counterclockwise, and when it collides with the atmosphere in front of the daytime hemisphere, it causes the trade wind. Trade winds move clockwise around the center of the irradiation in the daytime hemisphere, while solar winds move counterclockwise over the night side as shown in Fig. 1. On the other hand, solar winds above 500 km per second passing east side of the sphere of Earth's high latitude move the atmosphere from west to east. So the entire Earth's atmosphere is moving from west to east faster than the Earth's rotation. The interaction between moving charged particles and the other moving charged particles acts as parallel currents. In the inside of the clustered moving charged particles that repeat the collision, charged particles that are in parallel are chained and moved as a bundle. So, the solar wind keeps very high speed. If the static magnetic field is set for moving charged particles, the interaction among moving charged particles cannot be handled. According to a Haranov-Bohm effect, the magnetic interaction among moving charged particles must be deal with vector potential A here, B equals rotation A and B is a magnetic field. The action of force is a difference in potential, so the constant term disappears in the magnetic field B. A is the energy of the place relative to the unit current, and the energy of the place relative to the moving charged particles. It is proved by the fact that parallel current directly acts among the moving charged particles in the coil and outside of the coil as shown in Fig. 2. That is, the coil current is reversed between up and down against the axis of the solenoid coil, and the electron beam passing above and the beam passing below generate interference fringes. The components of solar wind are mostly hydrogen ions and electrons. The molecules in the atmosphere of the thermosphere are partially ionized by irradiation of electromagnetic waves or the solar wind from the Sun. Ionized charged particles of atmosphere added momentum of hydrogen ions of solar wind and move parallel to the solar wind. Since there are the magnetic coupling effect of parallel currents between solar wind and Earth's atmospheric ions, the acceleration effect of solar wind passing at high speed on the eastern side of the Earth's atmosphere is more powerful than the western deceleration effect. Thus, solar wind can explain why the atmosphere orbits the Earth faster. This effect decreases at cos phi as latitude phi increases and is lost in the polar region. Conventional understanding explains that the reason why solar wind does not reach the surface of the Earth is that geomagnetism prevents solar wind, but the mean free path of atmosphere on the ground is about micron meters. The real reason why solar wind does not reach the surface is due to collisions with atmospheric molecules. When water vapor condenses and rain falls at the top of cumulonimbus clouds, a descending airflow swirls in the direction of clock rotation occurs in the sky above cumulonimbus clouds. At the bottom of the cumulonimbus clouds is an updraft that rotates counterclockwise. These two swirling airflows are involved in the mechanism of the typhoon. Outer updraft and inner downdraft of a cumulonimbus cloud rotate in the opposite direction. The opposing airflow develops by the mechanism of the gears and forms the eye of the typhoon. The wind of a typhoon blowing up at the sea is in a counterclockwise direction. However, the track of the typhoon is the direction of rotation of the clock depending on the airflow of the sky atmosphere. Only the solar wind that collides from the outside can drive the trade winds and westerly winds that orbit the Earth regularly. The direction in which the solar wind blowing from the Sun changes with the seasons because the Earth's axis of rotation is tilted. The westerlies that orbit the Earth faster than the Earth's rotation are driven by the solar wind. On the other hand, in areas where the counterclockwise solar wind that accompanies the rotation of the Sun collides head-on, trade winds blow because the atmosphere is driven in the direction of clockwise rotation. In the tropics, trade winds blow from east to west, but at night they blow from west to east by solar winds passing on the Earth's sides. However, as shown in Fig. 6, the atmospheric flow blowing from west to east is above the trade winds. Therefore, the speed of movement of weather is slow, but it moves from west to east. Madden-Julian oscillations (MJO) are weather phenomenon in the western Indian Ocean. In MJO, wet wide area and dry wide areas are moving eastward with a repetition of very slow cycles of about 30 to 60 days. In tropics, cumulonimbus clouds occur in the daytime and thunderstorms occur in the evening. MJO, which is moving cumulonimbus clouds in large areas to the east in a slow cycle. The effect of trade winds is generated by solar winds at the sun side in the daytime. But the atmosphere from east to west is offsetting the effect of westerly winds moving from west to east at the night. The island of Luzon in the Philippines has a rainy season with trade winds from May to December. During this season, water vapor evaporated by the sun's irradiation moves from east to west during daytime. At nighttime, the atmosphere becomes an inverted and moves from west to east. So, in the evening, the easterly wind during the day collides with the westerly wind at night and there is a squall. However, from November to April, it is the dry season as shown in Fig. 7. This dry season is caused by westerlies blowing from the Asian continent. There are climate changes that occur due to the same cause in Luzon Island and Africa, which are located almost at same latitude. 7,000-year-old Sahara, where trade winds were blowing, was not dry. Where, the trade winds blow in the daytime, but at night the solar wind blows from the west to the east. So, the water vapor evaporated by solar irradiation moves from east side to west side during the daytime, but the water vapor is returned from west side to east side at the night. North Africa had changed from trade winds to westerlies for about 5,000 years. Then, the westerlies came to blow from the southwest in Sahara. The drying began by the westerlies. Plants decreased, and desertification advanced by the decrease of the plants. The effects of trade and westerly winds on the weather depend on the Earth's topography. Even if the four seasons round, the accumulated effects of seasonal wind in the area with wide land and the seasonal wind in the region with a wide of oceans will be different. At winter solstice of the precession as shown on left side of Fig. 9, westerlies blow from northwest at northern hemisphere during 100 years, so the northern hemisphere becomes cold. The last ice age ended about 10,000 years ago. Thereafter, Earth's precession gradually reduced the tilt westward of the axis of rotation, and it shifted the central point of the solar irradiation surface near the vernal equine to the northern hemisphere side as shown in the center of Fig. 9. So, the northern hemisphere warmed up during that period. As shown on the right side of Fig. 9, the precession summer solstice is warmed by south winds because it blows southwest in the northern hemisphere for hundreds of years. Tilt of Earth's rotating axis has been fixed almost 1 year. However, the direction of the Earth's rotation axis has been rotated with a very long period of Earth's precession. According to the Virial theorem, kinetic energy is equal to half of the positional energy in equilibrium. For examples, as an electron approaches to the nucleus of an atom, the rotational speed increases due to kinetic energy of half of the positional energy. When the boiled egg is rotated and grounded, it moves from the energy of rotation to the energy of gravity, so it stands up. There is the explanation that the precession of the Earth is caused by the tidal force of the Earth, but the tidal phenomenon is a phenomenon that reduces rotational energy and is not essence of the precession. Shell mounds tell us the living of human during several thousands of years ago, and the location of the coastline. The sea levels in the east coast of Japan rose from 6,500 to about 6,000 years ago. During this period, the North Pole tilt of the axis of rotation of the precession tilted 23.4 degrees to the due south. So the area where the trade winds blew north and continued to hit Japan's east coast for hundreds of years, so the sea level rose by 2 meters. Fig. 13 shows a good correlation between temperature changes by analyzing the atmosphere in the Antarctic ice and the amount of solar irradiation estimated by Milankovitch cycle at 65 degrees north latitude. Global climate change caused by the precession of the Earth's rotational axis should differ between the northern hemisphere and southern hemispheres, but the effect is not significant in Fig. 13. Conclusion. Earth's precession changes the irradiation angle of the Sun and the collision angle of the solar wind, which affects long-term climate change. When the solar wind collides with the Earth's upper atmosphere, moving charged particles affect the movement of the atmosphere around the Earth by a chain of magnetic coupling of parallel currents. It was clarified that the movement of the Earth orbiting the Sun continues to change the environment. Thank you for your attention.